Okay, now let's look at geomorphology. Let's start right away with drainage basin. Let's start with the question first with drainage basin. Um, um, the question says, match the concept below with the letters in the diagram. Write only the letter A to H next to the question number 2.1.1.1 up to 2.1.8 in the answer book. Now, the first question is, where is the source of the river? So the source of the river will be at B. This is the source of the river. That is where the river originates. And then water table. So this line over here is indicating the top surface of groundwater. So this is what we call water table. So water table, this is what is indicated as water table. And then water table will be indicated by the letter G. This letter G over here is indicating water table. And an interflow. So you must know what is water table. Let's start first with source. Source of the river is where the river originates. Water table is the top surface of groundwater, which means here we have water under the ground. What do you call the water under the ground? We call it groundwater. And then what is this upper limit? What is this upper limit of this water under the ground? We call it water table. Then we have an interflow. An interflow. Where is an interflow? An interflow is at A. So what is an interflow? An interflow is an area that separates the streams of the same drainage basin. So you have different streams. You have different streams there. And you have the main stream there. So these streams that you see here, they are separated. They are separated by these high-lying areas between them. It is called interflow. So what is an interflow? Is a high-lying area that separates the streams within the same drainage basin. Then, what do we have here? We have this drainage basin, this side, and we have another drainage basin, this side, which is indicated by this dotted lines there. So, this a drainage basin and another drainage basin. Now, this is a drainage basin. So you need to be able to define what a drainage basin is. The total area drained by the river system. Drainage basin is the total area drained by the river system. We call it a drainage basin, which means this entire area is a drainage basin. This entire area is a drainage basin because it has got a river system. Now we spoke of river system. It means you must also have another concept to define there, which is a river system. What is a river system? River system is equals to the mainstream. This is your mainstream. This is your mainstream. And all these rivers that are flowing into it are called tributaries. So the mainstream and all its tributary equals to the river system. So the whole area drained by the river system is called a drainage basin. So where is drainage basin? This is C. So it is indicating the boundary of a drainage basin. Then the river mouth. Where is the river mouth? The river mouth is at E, where the river flows into the sea. Where the river flows into the sea, we call that point a river mouth. Then we have a watershed. There is your watershed. There is your watershed there. We have drainage basin this side, another drainage basin this side. They are separated by a watershed. Don't confuse watershed and interflow. Interflow separates the streams within the same drainage basin, but the watershed separates two or more drainage basins. Watershed separates two or more drainage basin, but interflow separates streams within the same drainage basin. Then we have a confluence. We have a confluence. What is a confluence? What is a confluence? Confluence is at number D, Where is our D? This is our D. So a confluence is where two streams join. It can be a stream, it can be a mainstream and a tributary, or a tributary joining the mainstream. That point is called confluence, or it can be where two tributaries are joining each other. So long as the streams are joining, that point is called a confluence. And what do we see here? We call infiltration. The process of infiltration is the absorption of water by the surface. Hope we're fine with drainage basin. Then we have stream patterns. We've got different patterns that we have. We have studied different patterns. So we have dendritic pattern. What you should know, you must be able to describe it. You must be able to tell what is the underlying rock. Now let's look at the dendritic pattern. We have trellis pattern, we have radial pattern, rectangular pattern, centripetal, deranged, and parallel. So we have different types of drainage patterns. Let's look at few activities on drainage patterns. Let me just quickly look at the characteristics of drainage patterns. Okay. Sometimes you get an examination, they want you to give characteristics of those patterns. Now, dendritic pattern, what are the descriptions or what are the characteristics there? It looks like the branches of a tree. It does not look like a tree. It does not look like a tree, but it looks like the branches of a tree, because different trees will have different shapes, but the branches inside a tree will look more the same. And the tributaries join the mainstream at an acute angle. There's an acute angle that we are looking at here. There's an acute angle that we are looking at here. So that is the characteristics. And then where do we find dendritic patterns? Where the rocks have got uniform resistance to erosion. They have uniform or similar hardness. They have uniform or similar hardness. So that is your dendritic pattern. Then what do you have next? We have trellis pattern or trellised pattern, depends on how you want to pronounce it. Now, this is your mainstream. This is your other mainstream. So what do you see there? The mainstream are flowing parallel to each other. Mainstream are flowing parallel to each other. You can see this is the mainstream there, another one there. What you can see as well is that instead of acute angles, now the tributaries join the mainstream at a right angle. Tributaries join the mainstream at the right angle. And you can also see the tributaries are shorter. And then where do you find the streams? You find the streams in where there is alternating hard rock, gently sloping alternating layers of hard and soft rock. So here we have soft rock, that's why we have the streams, and here the surface is very strong or very hard and resistant, so there is no streams here. So there is soft rock where you have streams, hard rock, no streams. Soft rocks where you have streams, hard rock. So it's found where alternating soft rocks and hard rocks are found. Then what do we have? We have radial. Radial simply meaning to radiate, which means now water is falling into this high-lying area and the streams radiate. They flow away from the high point, and then it is going to be usually found where you might have a mesa or a butte or any high-lying area that can allow for that. And then we have rectangular pattern. As the name says, rectangular, the tributaries join at the right angle. So with a rectangular pattern together with the trellis pattern, what is similar with them? The similarity between rectangular pattern and trellis pattern is that tributaries join the mainstream at the right angle. But now we're looking at the characteristics of the rectangular pattern. The mainstreams also have a 90 degrees bend. The 90 degrees bend. So we've got two 90 degrees. The mainstreams bend at 90 degrees, and the tributaries also join the mainstream at 90 degrees. Then where do we find them? We find them we find the stream patterns where we have jointed igneous rocks, Then we have what we call centripetal. Centripetal, it is the opposite to centrifugal. So this one, sometimes the radial is sometimes called centrifugal, meaning that the streams are radiating away. But centripetal, the streams are flowing towards a low-lying area where the land has since subsided. And then what do we have here? We have the ranged pattern. The ranged pattern is usually, like the name says, the range. It doesn't have a definite pattern. The streams flow in and out of lakes. It is usually found where there has been a glaciation, or which is the moving ice or flowing ice. So that is where it is usually found. And then we have parallel pattern, and the parallel pattern is usually found where the gradient is very steep hill. Streams flow parallel to each other because of the steeper gradient. And then it is common along a ridge or a hill. Just like this other one, the trellis pattern, it is also common where you are going to find incline strata. Sometimes they say the underlying rock where you have incline strata. Let's move on with our patterns. Now, here are the activities on patterns. Identify drainage pattern A. This one, it looks like a radial pattern. You see the streams are radiating away. Determine the stream order of X in drainage pattern A. So what are you looking at here? You say this is stream order 1 and stream order 1. They are going to make stream order 2. So the pattern there is stream order. The stream order there is stream order 2. Give reasons for the direction in which the streams flow in drainage pattern. So the streams are flowing from the high-lying area. Give the reason. The streams are simply flowing from the higher lying area. How does the joining of the tributaries to the mainstream differ in drainage pattern A and B? You can see the joining here is acute. We have an acute angle, but here you can see there is 90 degrees angle. State two conditions associated with the underlying rock that contribute to the formation of trellis pattern. Two underlying. So number one, it is soft and hard rock, alternating soft and hard rock. That is the first one. And the second one, it is where you have inclined strata. That's number two. And it says, why are human activities limited in areas where drainage patterns A and B are found? Why are they limited? Human activities, number one, they are found where the areas are steeper. Number one. Number two, it is not easy to build in those areas. So it is steeper area with difficulty to build. So that is why they are not easy they are easily habitable. Land is steeper, it's prone to soil erosion, the soil is infertile, there's a risk of mass movement, high cost of developing. It's not easy to develop there. So there are a number of reasons that we can give why this is not easily habitable. Now, let's look at two other drainage patterns there. Identify drainage pattern in sketch A and B. So we can see the mainstreams are bending there at 90 degrees, which means this one will be rectangular, and this one looks like the one that we're looking at, which is the same one as this one, the same one as the first one that we're looking at here, which is the dendritic pattern. State the underlying rock structure and rock type on which the drainage pattern A developed. So the underlying rock here, it is igneous rock that is jointed. It is igneous rock that is jointed. jointed igneous rock or horizontal layered? Let's continue. Identify drainage pattern in sketch A and B. So sketch A, we said the drainage pattern there is rectangular pattern, and sketch B is dendritic. And then state the underlying rock structure and rock type. Underlying rock structure and rock type in drainage pattern A developed. We said number one, the rock structure is jointed, faults, or horizontal layered. Okay, then we have let's go back to okay. Explain how the underlying rock structure influenced the drainage pattern at A. What's happening here? Explain how the underlying rock structure influenced the drainage pattern at A. So what is happening there? The streams are following the joints. The streams are simply following the joints. 2.3.4 drainage density in B is low or high. Drainage density in B is higher than the drainage density in A. Explain the relationship between the stream order and drainage density. The relationship between the stream order and drainage density is that when the stream density is higher, the stream order will always be higher as well. And when the drainage density is lower, the stream order will also be lower. Explain how the slope or gradient and permeability of underlying rock influence the drainage density. So let's come to this page now. What are we looking at here? We're looking at drainage density. So as we are looking at drainage density, we must be able to define the concept drainage density. So drainage density is the total number of streams divided by the total area of the drainage basin. Total number of streams of a drainage basin divided by the total area of the drainage basin. Now, drainage density is influenced by two processes, infiltration and surface runoff. And there are also factors that influence drainage density, which is gradient, porosity, and permeability, type of precipitation, soil moisture, vegetation, and type of soil. Now, this is the game that I want us to play when it comes to drainage density. We said drainage density is influenced by infiltration and surface runoff. So that infiltration will result in low drainage density, and surface runoff is going to result in high drainage density. Because when there is more infiltration, there's going to be less water on the surface. But when there is more surface runoff, there's going to be more water on the surface. Excuse me. Now, let's look at the drainage density now. Excuse me. Let's look at drainage density at A. Let's look at the drainage density at A. Sorry, not A. That's not A. Drainage density at A. What's happening here? Yeah. Let's look at the drainage density at A. How is the drainage density at A compared to the drainage density at B? Now, The drainage density at A, we can say drainage density at A is higher. Now, here are the factors that are influencing drainage density. It's gradient, porosity and permeability, type of infiltration, type of precipitation, soil moisture, vegetation, and type of soil. Now, here is a simple question. Explain how gradient influence density at B. If you get that question, say explain how gradient influence density at A or at B. Let's start with B. If you are to answer that question, you say at B, the gradient is gentle. And because of the gentle gradient at B, there is more infiltration and there is less surface runoff. That is why the density is low. And now let's look at A. How did the gradient influence density at A? Then you say at A, the gradient is steeper and therefore there is more surface runoff and less infiltration. That is why we have high density. Then that is how you approach your question. Sometimes they say you explain how did vegetation influence density at A. Then you say at A, there is less vegetation. Because of less vegetation, there is more surface runoff and there is less infiltration. That is why the density at A is higher. They say, how did vegetation influence density at B? At B, there is more vegetation. That is why at B, there is more infiltration and less surface runoff. That is why the density is lower. Then we have another factor like porosity and permeability. And porosity and permeability is the same as the type of soil. It's the same as the type of soil because porosity will determine whether the soil is able to allow infiltration or not. Then what are you saying? Saying at A there is low porosity. What do you mean by low porosity? There is fewer pore spaces. You're saying at A, there are fewer pore spaces. Because of fewer pore spaces at A, there is more surface runoff and there is less infiltration. And that is why we have higher density. But the opposite is taking place at B. At B, the area is high or has high porosity. Because of high porosity, there is more infiltration at B. And because of more infiltration at B, there is less surface runoff. That is why at B, there is lower density. Remember we said density is influenced by two processes, infiltration and runoff. And that infiltration and runoff is also influenced by these factors. Then we say type of precipitation. Now it means at A, there was heavy rainfall. There was heavy rainfall, which means that it rained quickly. There was not enough time for it to infiltrate. That is why we have high density. But at B, the rainfall was slow, soaking, more infiltration, and therefore less density. Because there is more infiltration and less surface runoff. And then soil moisture. What does it mean, soil moisture? It means at A, the soil is saturated. At A, the soil is saturated. And because the soil is saturated, what do we mean saturated? The soil is full of moisture. And therefore, there's going to be less infiltration, but there's going to be more surface runoff. That is why A has higher density than at B. And it means at B, the soil is dry. because of the dry soil, there is going to be more infiltration. Then because of more infiltration, there's going to be less surface runoff and lesser drainage density. And we have already spoken about vegetation, and type of soil is the same as porosity and permeability. It means the soil at B is more permeable. Now, permeable meaning that the soil is allowing for water to infiltrate and therefore resulting in low density. That is why we have fewer streams. But at A, it means the soil is less permeable and therefore more surface runoff and less infiltration. Now, let's continue with stream orders. So stream order is something that we have done. You can also refer to the video that we have shared earlier this year. So what do we have there? We have stream order 1 and stream order 1 making stream order 2. But when you add stream order 1 and stream order 2, we remain at 2. Because the stream orders of a different order, when you add them, they remain at the highest order. They don't change. But when you add 2 and 2, they will give us 3. When you add 2 and 2, stream order moves to 3. But when you add 1 and 1 is going to give you 2. 2 and 2 will give you 3. 3 and 1 remains at 3. 3 and 2 remains at 3. But 3 and 3 moves to 4. So that is how so what you should also know is that when you see the drainage, the order being higher, it is also showing that the density is higher. But here, so when you're looking at the drainage density at this point, the drainage density at this point is going to be lower than the drainage density at this point. Because here, what do we have there? We have third order streams, but here it end up at second order. So sometimes the examiners ask you interesting questions when it comes to stream order. They can ask you, how will a prolonged rain influence the stream order? How will the prolonged rains influence the stream order? So if there is rain that takes place for longer periods, or it is raining for longer period, it means more streams are going to develop. So which means the stream order will also increase. And then they can also ask you, how will drought influence the stream order? So what will happen if the drought takes place? It means the first order streams will be drying out. And if the first order streams are drying out, it means now we'll be left with the second order streams and the third order streams. Now the second order stream becomes stream order number 1, and then stream order number 3 becomes stream order number 2. So what is happening to the drainage density? The drainage density is becoming lower. And then as the drainage density becomes lower, how is that influencing the stream order? The stream order is also becoming lower. But if we increase rainfall, we're going to increase the number of streams. And then we're going to increase the number of stream orders. The stream order is increasing. So it goes now from 4 to 5, 5 to 6, because there is more surface runoff and there are more streams. But if there is drought, now they reduce. The stream order 1s become the stream order 2s, and the 2s become 3. So that is an application type of question that you might expect to get. Or that could be, it's just, you must apply your mind when you're reading these questions. Okay. Now, what are we looking at here? We're looking at a river discharge. River discharge. What is a river discharge? A river discharge refers to the volume of water in a river as it passes a specific point in time. A river discharge is a volume of water in a river as it passes a specific point in time. And then this river discharge can be high at a particular point in time, or it can be low. And then what we see again is here, when river is flowing, river can flow in two ways. River can flow in a gentle surface or in an uneven surface. When a river flow in an even surface, in a even surface, in a lower course, it's going to flow in a characteristics called laminar flow, where water flows as parallel sheets, as you can see in the diagram here, and river bed is even or smooth, and there is less erosion, and it occurs mainly in the lower course of the river. So at this stage, you can say the river is gradient. It is graded. And then here in turbulent flow, water flows in turbulent riverbed is uneven. What do we mean it's uneven? There are waterfalls, there are rapids there. There is more erosion, and this process is more likely to take place in the Pacos. But here, there is more balance between erosion and deposition. Here, we have a dominant erosion as a process. Okay, now we are looking at the longitudinal profile of the river. What is a longitudinal profile of the river? Is the view of the river from where it starts, which is the source, to where it ends, which is the mouth. Now, when you're looking at the river again, long profile of the river, it has the upper course. So this will be the upper course, and this is the middle course, and this is the lower course. So the river in its upper course has got a steeper gradient, and the water is flowing fast. There is dominant of downward erosion or vertical erosion, and the area has got waterfalls, got rapids, interlogging spats, and you can see the volume of water is very little. Then in the middle course, you can see the volume of water is increasing because more tributaries are joining the river. And then what is happening? The gradient is gradual. The river flows slower because it's no longer as steep in the upper course. It's getting gradual. And there is lateral erosion. Lateral erosion means sideways erosion. Means now the river bed, not the river bed, the river is becoming wider. The river valley is becoming wider. The river valley is becoming wider. And then we have the lower course. What is happening in the lower course? What is happening in the lower course? The river is almost flat. The river is almost flat. And what is happening there? You can see it is almost flat. The river is flowing very slow. There is dominance of deposition. Then we have different features that are occurring there: oxbow lakes, deltas, meanders, marshes and flays, braided streams, sandbanks. So these are what you can expect to find in the lower course of the river. Now let's quickly look at these questions here. They say various options are provided as possible answers. No. The question is, let's look at the first question. The profile from source to the mouth shows the dash of the river. From the source to the mouth, what does it represent? It shows the length of the river. And then what do we have there? The stages. Now these stages are scrambled up. The stages are scrambled up. What you must do, you must choose the correct order. It says here, the stages X, Y, and Z are stages X, Y, and Z. So it must be upper course, it must be middle course, and it must be lower course. So it will be upper course, middle course, and lower course. So the correct answer there will be C. Describe the river valley at X. So we're looking at the river valley at X. Is it wide and shallow? Is it wide and deep? So the correct answer there, it is narrow and deep. It is narrow and deep. And then at Z, the river has a laminar flow due to a river bed. How is the river bed at Z? How is the river bed at Z? Is it rough and uneven? Is it steep and even? Is it gently sloping and even? So the correct answer there will be number C. Slope T on the meander is the what slope? Slope T. So you can see slope T here is deeper, showing that there is more erosion at T. There is more erosion at T because water is moving faster at T. So slope T is going to be called an undercut slope, and which means the slope S will be called a slip off. That is where it is shallow here. At S, this is a slip off. And then this one over here is the undercut. And then which means this one here is going to be gentle, and this one over here will be convex as well. Slope S on the meander is associated with A. Slope S. Is it associated with the steep gradient and deposition, gentle gradient and erosion, concave slope with erosion, convex slope with deposition? So here it will be convex slope with deposition. Okay, let's move on to the next question now. So this is a map showing the river in the upper course. So this is what we call rapids. This is what we call rapids, and this is what a waterfall is. So these are the features that you're going to find in the upper course of the river, and then this is a map showing the upper course of the river. You can see the contour lines that are very close to each other, indicating that the gradient is very steep. And this is the middle course of the river. You can see now with the contour lines being far from each other, you can see there's a lot of dams there, indicating that the gradient is gentle there. And then what do you have there? This is the lower course. Then you see the braided streams there. So don't confuse braided streams to your deltas. Your braided streams, the rivers is going to break. Now, this is the lower course. I was saying you must be careful when you're looking at the braided stream, as compared to deltas. So this is a river in its lower course. What is the evidence that is a lower course? Number one, there are marshes and flays that you can see there. Number two, you can see the well-developed meanders there. You can see braided streams there. You can see wider floodplain. You can see meandering there. So this is the features that you find in the lower course of the river. There is what you call your oxbow lakes there. You have your meanders there, and then you have abundant channels of the river there. And then this is what you call a delta. So a river has now broken into distributaries. The river has broken into distributaries as it flows into the sea. The river has broken into distributaries as it flows into the sea. So this is your features that you find in the lower course of the river. Now, what we have here, we have river grading. We have two we have an ungraded river. This is where you are going to have turbulent flow. Why do you say this river is ungraded? Because there are nick points along the course. And then there is a dominant erosion. Erosion is dominant here. There is dominant erosion because there are still obstacles along the course of this river. But this one is a graded profile, which means there is a balance between erosion and deposition. So in profile, gradient profile, we say this is in equilibrium. There is no dominant process. But here, because there are obstacles or there are nick points, and then you must be able to define what's a nick point. So here is a gradient of the river, and at this point, it changes suddenly. It changes suddenly. Here it is, it changes suddenly. Here it is, it changes suddenly. So where there is a sudden change in the gradient of the river, we call that point a nick point. Now, we're looking at a cross profile through a meander. It is the same diagram that we looked at in the previous questions when we were looking at the a meander. So this is what we have. We have a river flowing on the outside and it's flowing faster. And because it's flowing faster, there's going to be more erosion. And on the inside, the river is flowing slower and there's going to be more deposition. And then if you are to draw a cross section of a meander, you must know it is either a Nike that is straightforward or it is a Nike that is in reverse. So where you have your undercut, it will be deeper, and where you have slip off, it will be shallow. So you just draw a Nike like that, depending on which side. So here you're going to have the river being deeper because it's undercut this side, and this side is shallow. So if the river, if it was bending to the other direction, then your Nike will face a different direction. You just draw a Nike like that. It's a Nike tick. Just tick a Nike tick. That is your cross profile through a meander. It can be a Nike in the right direction, or it can be a Nike in the opposite direction. So why is the undercut deeper? Because the water is flowing faster and there's going to be more erosion. Why is the slip off shallow? Because the water is flowing slower and there's going to be more deposition. Okay, let's continue. Now, let's quickly go through the river capture or stream piracy. What is stream piracy? Is when an energetic stream diverts headwaters of a less energetic stream. When energetic stream diverts headwaters of a less energetic stream. So this is simply an animation of is a simple animation of a river capture. So what do we have? We have two streams, or we have two drainage basins separated by the watershed. So for a river capture to take place, we need two processes. The first process is called headward erosion. What is headward erosion? Is when you see this river is flowing in this direction, but erosion is taking place in the opposite. We call that process headward erosion. When the river erodes towards the source, the water is coming from this way, but it's eroding in the opposite direction. That's what headward erosion. But now, these two streams are separated by the watershed. So what must happen? Number one, this watershed must be lowered and be removed or shifted. So that process of lowering and shifting of the watershed is called abstraction. So the processes that are needed for river capture to take place is headward erosion and what we call the shifting and the lowering of the watershed, which is the abstraction. It is the abstraction of the watershed. Now, as you can see, it means now this river is flowing on a steeper gradient, and this one, which is river B, is flowing on a gentle gradient. So because river A is on a steeper gradient, it's going to do what we call headward erosion, lowering and removing the watershed through the process of headward erosion. And then once that takes place, the two rivers are going to join. And then when the two rivers join, river will now be flowing to the lowest point, which means now river A is on a steeper gradient, but at a lower lying area. This one is on a this one is on a gentle gradient, but on a higher lying area. So then at the point where they join, what's going to happen? This water is going to flow towards the lowest point. This water is going to follow a steep gradient towards the lowest point. And then what is happening now? This is what we call river capture or stream piracy. And we must be able to label the features of a stream piracy. Number one, this is a point where these streams joined. So what we call it, elbow of capture. And then this river that has taken water of another stream is called a captor stream. And then this stream that has followed the stream that is flowing on a lower lying area is called captured stream. And this stream that no longer receives water because the water has been diverted is called a misfit stream. And then this area where river used to flow, but there is no longer water flowing there. This area is dry. It has got gravel. This area is now called the wind gap. So these are the features of the stream piracy. Now, what will be the disadvantage for the people that are living downstream where the river has been, at the downstream where the river has been diverted or where the river has been changed its direction? So there's going to be water shortage. For farming, there's going to be less fishing, there's less recreation, and there's less industrial activities because of the shortage of water. But now, what is going to happen where the river has gained more water? The soil will be fertile, there's going to be more water for farming, the economy will grow, there are high chances of flooding and high chances of erosion. So, this is what might happen to the people that are living here. But sometimes the examiners don't want to know about the impacts to the people living downstream or to the people living downstream at the misfit or to the captor stream. Sometimes the examiner will ask you to give a impacts of this process on the rivers themselves. What is the impact of river capture? What is the physical impact? So it means now what will happen to the river itself. So it can be what will happen to the captor stream or what will happen to the misfit stream. So you must be careful. Sometimes it say you can be asked to answer the question, what will happen to the people around? But sometimes they ask you what will happen to the rivers themselves. Now, what is going to happen to this river? The river is going to have more water. The river will rejuvenate because it is going to regain more energy. The river can cause a lot of flooding. The river is going to have more vertical erosion. The deposition will decrease because now the river has more energy for erosion. Then what will happen to the site? There is going to be less energy. So if there is less energy, there's going to be more deposition. With more deposition, there's going to be the river is also going to be smaller than the valley that is flowing through. The river becomes smaller than the valley that is flowing through. So those will be the challenges that this is going to experience. So you must be able to answer, to respond to what will happen to the people that are living downstream or what will happen to the streams themselves. The stream that has captured more water is going to have more water. The volume of water increases. The speed of water increases. Vertical erosion increases. There is higher volume of water, like I said. But when you look at the stream that has lost or that has been captured, there's going to be less volume of water. Because of less volume of water, less erosion, more deposition. Okay, that's another example of river capture. Now, here is the activities that you need to do. Define the concept river capture. Is when an energetic stream diverts headwaters of less energetic stream. State one condition needed for river capture to take place. Number one river must have more water than the other. One river must be flowing on a steeper gradient. Number three, one river must flow on a lower lying area and the other one on a higher lying area. So those are the factors that are going to result in the river capture. Now, the question says, draw a sketch to illustrate the area after river capture has taken place. You can see here, river capture has not taken place. So we still have the watershed abstraction process has not taken place, though headward erosion is still taking place, but it has not yet cut through the watershed. Now, let's see what has happened. Now, in the next step, what has happened is that headward erosion continued to take place. After headward erosion took place, now the stream that is on a lower lying area, but on a steeper gradient, managed to capture the stream that was flowing on a higher lying area, but on a gentle gradient. So this is what has happened. And now, must also be able to answer these questions. Will river Y or river Z experience rejuvenation? What is rejuvenation? It is when the river renews its erosive ability. When the river renews its erosive ability, or when a river begins to erode vertically again. We call that process river rejuvenation. Now, the saying 2.4, 2.5 and 4, will river Y or river Z experience rejuvenation? So this is river Y. It is going to experience rejuvenation because it's going to gain more water. But river Z cannot rejuvenate because it has lost water. So it has lost energy. The question, give reasons for your answer. We have already given that answer. And explain the impact of the change of the capture stream. So we have already explained what will happen after a river takes water from another river. It is going to have more water. It's going to flow faster. It's going to have increased vertical erosion. The active erosion will cut into the valley forming terraces, the softer rock. So this is a little bit complicated answers, but you need to just simplify that. You must know that the volume of water is going to increase, erosion is going to increase, deposition is going to decrease, vertical erosion is going to increase. There's going to be high chances of erosion and not erosion, of flooding. So you need to simplify your answers. Don't complicate your answers. Okay, there is your rejuvenation. What is rejuvenation? Is when river starts to flow faster. It has renewed energy. So what do we have there? We have a river in its upper course, middle course, and lower course. So what you need to know, we spoke about the neck point where there is sudden change in the gradient of the river. Now, let's look at evidence of river rejuvenation. So number one, what is the evidence that river rejuvenation has taken place? We can see different features. A nick point is a point where rejuvenation will take place. So once you see nick point, you must know rejuvenation has taken place. So we said a nick point is where there is a sudden change in the gradient of the river. But that is the point where your rejuvenation takes place, where there is a sudden change in the gradient of the river. That is where your rejuvenation takes place. And then incised meanders. What are incised meanders? Incised meanders are simply deep meanders. Rejuvenation has taken place and the river was already meandering. So when the river starts to gain energy, when the river starts to gain energy, when the river starts to gain energy, but the river is already meandering, what is going to happen to the meander? The meanders are going to become deeper. So once the rivers becomes deeper, we say the rivers are in the trench, or the rivers, or the meanders are incised or are entrenched. A trench, a trench is a hole. So this is a meander in the hole. So the evidence of river rejuvenation is incised meander or entrenched meander. And then you can see now we have terraces, meaning that the river valley was at this point, then it came to that point, then it moved to that point. So it is terraces. It is terraces that indicate that rejuvenation has been taking place over a period of time. We can also have what we call a valley within the valley. So you have your valley there, and the rejuvenation takes place, which means now the river cuts deeper in the existing valley. So that process is called valley. That feature is called valley within the valley. So we have different features that indicate river rejuvenation. And last question that I want us to look at is the river of drainage basin management. This is a common question. I have seen this question in all examination questions from 2021, 2022, 2023, 2024. There was always river management there, or drainage basin management. So this is a question that usually comes. This is a question that usually comes in a case study or in an infographic. So what is important with this thing is you must know the strategies. Suggest 3 sustainable strategies that can be used. So most of the answers that are common with this will be the strategies. What is key here? Okay, you must know what does the abbreviation DWA stands for. DWA stands for Department of Water Affairs. But usually this, I say, comes in a form of a extract. You'll have an extract that you have to read. That extract could be that extract can be what you call infographic, or it can be just an extract, one extract that you read from. So most of the questions there will be based on the source that you have. But what is important is strategies. So this sustainable strategies to implement to maintain the quality of water. So I want you to understand that when you speak of strategies, the first strategy that you should give if you are answering any question, it must be education and awareness. It does not matter what the question is. If it's a sustainable strategy to reduce urban heat island, you must know its education and awareness. If it's a strategy to keep the rivers clean, you must know its education and awareness. If it's a strategy to reduce the impacts of tropical cyclone, it is education and awareness. If it is a strategy to reduce the impacts of mid-latitude cyclone, it's education and awareness. So education and awareness is the first strategy that you give when you are given any problem, because you cannot solve any problem when you don't know anything about it. So first, you must know about the problem. You must be made aware of the problem. And then that is the only time you'll be able to solve the problem. You can't solve the problem that you don't know. So education and awareness is the first strategy to solve all kind of problems that you might face. So now let's look at what strategies you can use to solve the problems. I said I'm not going to look into many questions here because the extract that you're going to get for the final paper is going to be different from any other extract. It's going to be different from any other extract. All you need to do, you need to read through the extract, you need to understand the extract. But when it comes to the strategies to solve any problems, I want to emphasize that one, that education and awareness is key to solving any other strategy that you can get. So depending on other strategies, one of the strategies to protect the rivers is to do buffering, whereby you build boundaries to stop people from accessing the river. You can also make legislation. One of the things that you can do in order to solve problems is you can legislate. You can legislate. You can make laws. You can make rules that tell people how to behave. So rules and legislation. And then in order to preserve water, we can also uh, conserve wetlands. You know what wetlands will do? Wetlands are going to clean a river. They serve as a sponge. They absorb the impurities there and allow water to flow and the water that is being cleaned. So when it comes to these strategies, please, the strategies are very practical. They are very applicable. And then you need to think thoroughly about them. And then drainage, basin, or river management. River management. I expect every person to get 15 marks out of 15 marks. Why? Because the questions there are application questions and they are going to vary from question paper to question paper. But most of the question papers that I have seen, they had drainage, basin, or river management. And I want to say at this point in time, I thank you for paying attention, and I'm going to add map work activities in the next session. I thank you.